Hello students, in this week's video we're moving on to applications of integration. We'll be solving problems, sums involving trigonometric functions, exponential and logarithmic functions. Do get ready a pen and some papers and practice along with me. Let's look at some concepts before we move on to solving problems involving definite integrals. Supposing I have a straight line which is y equals to x plus 1. If I'm going to substitute x to be 1, then I will get y coordinates to be 2. If I'm going to substitute x to be 3, then I'll be getting the y coordinates to be 4. And if I'm going to find the area of that shaded region, which is a trapezium, how do you go about doing it? Yes, I will be using this formula, which is half times sum of the parallel sides times the perpendicular height. And that will give me 6 units squared. However, there's another way of finding the area of the shaded region, and that involved the concepts of integrating your x plus 1, putting in the limits. How do we do it? When I integrate x plus 1, I would have half x squared, or x squared over 2. Integrate 1, you get x. So you end up getting half x squared plus x. And then we're going to substitute in the limits. The upper limits is 3, the lower limits is 1. And you see that I will get the same answer as what I've found using the formula to find the area of a trapezium. So the second method of finding the area of the shaded regions is using this concept called the definite integrals. And for the next few slides, we'll be solving problems involving definite integrals. Right, let's look at question 2a. So what we need to do first is to integrate 3x squared minus 2x plus 5. And that gives us 3x cubed over 3 minus 2x squared over 2 plus 5x. The upper limits will be 0, the lower limits is negative 1. Right, so first of all, we just substitute x to be 0 into each term. And then minus away, minus. The second part will be substitute x to be negative 1. A few things to take note, and that is, after doing the integration, it's best to simplify it before you do any substitution. So 3x cubed over 3 will be simplified to be x cubed. 2x squared over 2 to be simplified to be x squared. And of course 5x remains as 5x. And where do I get the 0? Because if you substitute 0 into x cubed, 0 into x squared, 0 into 5x, you end up getting a 0. Then you minus away the second portion where you put in the lower limits, which is negative 1. And it's very important that you bracket it. And so for this portion, if you use your calculator correctly, right, you will be able to get the answer to be 7. So this is how you apply the concepts of definite integrals. Right, let's look at the next questions. So what we have done here are what we have done earlier on when we deal with indefinite integrals. If you were to recall, indefinite integrals, the answer would need to have, you will need to add plus c, which is an arbitrary constant. Here, we're dealing with definite integrals. Means exactly we know what area we are finding. In the second slides they have shown you, the area of the trapezium. If you know exactly which portions of the area under the curve or under the straight line you're finding, that's called definite integral. So integrating 6x minus 3x to the power half is nothing new. We've already done it in indefinite integral. Alright, so to integrate 6x, you get 6x squared over 2. Integrate x to the power half, we get take the half plus 1, that give you 3 over 2, divide by 3 over 2. Now before you substitute into the limits, it's best to simplify it. So therefore, 6x squared divided by 2 will give you 3x squared. This one, you can just use your calculator. This here means 3 divided by 3 over 2. And if you use your calculator correctly, that will give you 2. It means 3 times 2/3. You flip the second fraction, and that gives you 2. Alright, so remember, okay, to simplify it before you do the substitution. Alright, and then just watch out that when you put in the steps here, you use square brackets. Okay, you use a square brackets, not curly brackets or whatever. Use a square bracket. And then the next thing is to substitute the values of our x to be 4, which is the upper limit, minus away when you substitute x to be 1, which is the lower limit, and use a calculator to work this out. You will get 31. Okay, let's look at the next one. So for the next one, we have to write it as a negative index. So that will give us, yes, the bracket 5 minus x to power negative half. So how do we integrate it? We take the power plus half, which give us, the power plus 1. Half minus half plus 1 gives you half. And then divide by half times the differentiation of whatever is inside the bracket. Differentiate 5, we get 0. Differentiate negative x, we get negative 1. Okay, and of course, put in your square bracket, and then your upper and the lower limits. And then simplify it before you do the substitution. Okay, so this one you can just easily use the calculator. Take 1 divide by negative half. So 1 divided by negative half will give you negative 2. Alright, so the next step is just to substitute your x to be 2 and x to be negative 4. And use your calculator correctly. Okay, make sure you have all the brackets, square brackets, and all the curly brackets, and you end up getting 2.54. Right, let's do question 3. Question 3 is nothing new. We have done this sort of questions when we are managing indefinite integral. Right, so part I, we're supposed to differentiate using quotient rule, right, and then subsequently make use of whatever answer I have for part I to find the values for the integral for the second part. Alright, so we're going to use quotient rule to differentiate 2x over square root x plus 1. So we're going to let this, the numerator be u, denominator be v. So I would have du over dx equals to 2, and dv over dx will be, alright, this v will be bracket x plus 1 to the power half. So when you differentiate it, I bring out the half, take half minus 1, that gives you negative half, times differentiation of this will give me 1. So this I will end up having 1 over 2 square root x plus 1. And you can plug it into your quotient rule, which is your v du over dx minus u dv over dx, and then times v squared. Alright, so this is what I have. V, which is square root x plus 1, times du over dx is 2. Alright, and then so on and so forth. Okay, so the next thing I'm going to do is I'm just going to multiply the numerator with this one here, so to get rid of my fraction. Okay, so what I would end up with will be the square root. Let me erase this. What I would end up will be this multiplied by this will just give me x plus 1 times 2, which is 2x plus 2. And then, of course, half times 2x. This will end up getting x only, and this and this will goes off. So that x plane minus x. And I have 2 of this and 1 of this, so end up getting a cube there. If you simplify further, this is what you get for part I. Alright, so from part I, this is what we have. So we're going to add the integral sign to both sides. This is what we have done also when we manage problems involving indefinite integral. And then what we're going to do? Yes, we're going to multiply both sides by dx, because when you integrate, we need to integrate with respect to dx. And then the next thing is that, of course, this and this can goes off because integration is the opposite of differentiation. Okay, and I'm going to multiply by 4. Why do I want to multiply by 4? Because look at what you're supposed to find. You're supposed to have 4x plus 8 at the numerator. And currently, what we have is only x plus 2. So therefore, I need to multiply with a 4. But we're dealing with the equation. If you're going to multiply with 4 on the left, then you must multiply with 4 on the right. Okay, so that will give us, yes, so I would have 4 times x plus 2 give me 4x plus 8, which is exactly what I need to do. And then it's equals to 8x over square root x plus 1. Alright, so since we're dealing with definite integral, I'm going to put in the limits. Right, and then you substitute in the first part, substitute x to be 8. So how do I end up getting a 3? It's because square root 8 plus 1 will give you square root 9, and that gives you 3. That explains this part here. And for the second time, when you substitute x to be 3, you get square root 3 plus 1. That gives you square root 4, and square root 4 is 2. So that explains this part here. And you just use a calculator to work this out to get 9 1/3. Right, let's look at the next question. The next question involves trigonometric functions. Alright, so we're going to integrate 3 cos 4x minus 2. So integrate cos, you should get sine. So integrate cos 4x, you will get sine 4x. But you need to divide by differentiation of 4x, which is 4. So what you'll be getting will be 3 sine 4x over 4 minus 2x. Alright, so we're going to substitute your x to be pi over 6. So if I'm going to take 4 times pi over 6, this will give me 4 pi over 6, which is 2 pi over 3. So that explains how I get this. Okay, right. So and then how do I get this? Because when I substitute your x to be 0, I will end up getting 3 sine 0 over 4 minus 2 times 0. And of course, sine 0 is 0. So 0 minus 0 will give you 0. So that explains my 0 here. Okay, so this one here, the questions did not say express your answer in exact value. So it's not really necessary to express your answer in exact value. But however, since we have done trigonometry and we know the special angles such as 30 degrees, 60 degrees, 45 degrees, these are special angle, right? Special angles will give us trigo ratio to be insert. So I think we can just practice leaving our answer insert. So 2 pi over 3, if you convert it to degree, is actually 2 times 180 degrees divided by 3. That gives you 120 degrees. So sine 120 is equals to sine 60, which gives you square root 3 over 2. Okay, so we have 3/4 times square root 3 over 2 minus pi over 3. And if we simplify further, this is what you get. Alright, but if you leave your answer into 3 significant figure, you will not get it wrong because the questions did not say leave your answer in exact. If the question says leave your answer in exact, then this is exactly how you should leave your answer in. Right, let's look at the next questions. So the next question is integrations of the exponential function. So when integrate e to the power x, we just get e to the power x. So you have e to the power x plus x, and then just put in the limits. Alright, so if you use a calculator, e to the power of ln x just basically give you 5. So that would be 5 plus ln 5 minus 1. And that gives you ln 5 plus 4. So this question is relatively manageable. Alright, the next questions involving integrations of logarithmic functions. Alright, so to integrate, right, we just pull out the constant 3. So that's 3 over 1. So this one here, if you're going to simplify it further, it means 3 over 1 times 1 over 2 minus x. So this one, when I integrate it, I will have ln 2 minus x, then divide by the differentiation of this, which is negative 1. Then you put in the limits. But simplify it first. Always simplify it first before you put in the limits. So 3 times 3 over negative 1 will just give you negative 3. So that's negative 3 ln 2 minus 1. Put in the limits, x to be 1 first, and then x to be 0. And then use your calculator. Oh, here you can leave it as 3 ln 2. Or if you use a calculator, you can just work it out and express the 3 significant figure. Let's look at part D. So this one here, you can simplify it to be 2 minus 3 times 1 over x. So when you integrate it, you get 2x minus 3 ln x. Then you can put in the limits. Okay, so here, if you are asked to leave your answer in the exact form, then we need to do a little bit of simplifications. We need to write ln 4 as ln 2 to the power of 2. And then you can apply your power law for logarithmic functions. Bring the power down. That will give you 2 ln 2. And that will give you 8 minus 6 ln 2 minus 4 plus 3 ln 2. So you can simplify further to be 4 minus 3 ln 2. So this is leaving your answer exact. Okay, I'm showing you this just in case the question specifically asks you to leave your answer exact. Otherwise, you can just use a calculator and work out the answer, put the 3 significant figure. Right, let's look at the next question. So the first few questions are just basic applications of definite integrals. So for question 8, there's a little bit of variation, but it's not difficult. It's just that the upper limit is a unknown. Alright, we're supposed to find the unknown k. Right, but the concept remains the same. Basically, I just need to find the integrals of 3 bracket x plus 2 to the power of 2. Right, so I'm going to just pull the 3 out because you just need, what we are interested in is just to integrate bracket x plus 2 to the power of 2. Alright, so this is what you get. Alright, the power 2 plus 1 gives you 3, divide by 3, and where do I get a 1? Because when you differentiate x plus 1, differentiate x plus 2, you differentiate x, you get 1, differentiate 2, you get 0. So basically, you just end up 3 times 1. And then simplify it before you sub in the limits. How do you simplify it? 3 means 3 over 1. So basically, it's just 3 divided by 3. Okay, this one means 3 divided by 3. You can just cancel off. 3 divided by 3 gives you 1. So the next step will be like this. Then you sub in your upper limit, which is k. So k plus 2 to the power of 3. Sub in the lower limits. So when you sub your x to be negative 2, basically you just end up getting 0. So this is what you get. Alright. And this is what you get. And you're going to cube root the 64, which gives you 4. And so therefore k will be 4 minus 2 gives you 2. And that's it. Right, so let's look at the next question. So first of all, I'm going to explain what this means. Right, so if you understand that definite integrals is just to find the area under the curve or area under the straight line. So what it means is that I have a function hx. We don't really have to worry. Hx, it may look like something like that. And then we're going to take limits from negative 1 to 3. So this area, okay, this shaded region will have area, oh, it's negative 2. So it will be below the x-axis, sorry, below the x-axis. So this is what it means. Alright, so this is what it means. Okay, so what we need to find now is if I'm going to find the area from 3 to 3, what does 3 to 3 means? So 3 to 3 means that it's like the upper limit is 3, it goes to -1, and then -1, you go back to 3. So we're actually finding limits from, what we are finding, it's the limits from 3 to -1 plus -1 to 3. Okay, if you understand what I'm trying to do here. Okay, so 3 to 3 means I'm getting from, you see the arrow, I'm getting from 3 to go to -1, and then plus -1 back to 3. So 3 to -1, the area is -2. But for this one here, -1 to 3 is the reverse. It's the reverse of 3 to -1. So I need to minus 2. And you'll see that actually what I end up with is 0 unit square. It's just like I stay at where you are. I don't move at all. Right, so for part 2, just pull out the 5. Right, and then you know that this one here, the area will give you -2. So it's just basically 5 times -2 gives you -10. Okay, the next one, it's, you will see the limit is the reverse. Okay, so I need to negate your negative. Yeah, it just, so what it means is that if I'm going to integrate from 3 to -1, yes, I just need to negate this guy, negate it. So I change my limits. So that will give me 5 pi over 2 times negative times -2. And that gives me 5 pi. Alright, so question 12 is similar to question 8. Okay, except now that we are managing exponential functions. So part I is just to differentiate 2x e to the power of 2x, and then we're going to use the part I answer to do part 2. So the concept is similar to question 8. Okay, so we're going to use product rule to do that. So you're just going to let 2x to be u and this to be v. Right, so you have u dv over dx. So when you differentiate e to the power of 2x, you will get e to the power of 2x, then times differentiation of the power gives you 2. So you end up getting 2e to the power of 2x, which I explain here. Okay, and of course differentiate 2x, you get 2. So there's a common term there, which is 2e to the power of 2x. 2e to the power of 2x, common term. So that is part I. Okay, so we're going to use part I to do part 2. How do we do it? Yes, by adding your integral sign. Yes, but before we add the integral sign, it's best to expand this. It's easier, it's manageable. I'll explain to you why. Expand it first and then add your integral sign. Okay, and why do I have to pull out the 2? Because look at what I'm supposed to find. I'm supposed to find 2x, e to the power of 2x. But here what I have is 4x. So I need to pull out my 2 so that this is exactly what I'm needed here. See? And I'm going to make star the subject. And of course this and this can go off. Alright. I'm going to divide by 2 on both sides. So 2x e to the power of 2x divided by 2, the 2 and 2 cancel off, left only this. This divided by 2, of course, explain the half there. And we're dealing with a definite integral, so of course you have to put in your limits, which is between 0 to 1. You have to put in the limits. So now I have to substitute x to be 1 and then x to be 0. Okay, so we substitute x to be 1, then of course this will end up e to the power of 2 minus half e to the power of 2. And if you substitute to be 0, this will be gone 0, right? This will be 0 minus half e to the power of 0. So that will give you negative half, because e to the power of 0 is 1. So that explains this. Okay, if you simplify further, right, so this is exactly what we asked to show here. So bracket shown. Right, so sometimes the questions will involve partial fractions. Okay, if you recall, we have done that also in indefinite integral. So part I is to express the fractions given into partial fractions. Okay, so we have one linear and one repeated linear. One linear and repeated linear, yes. So that will be a over linear plus b over x plus 1 plus c over repeated linear. Okay, and then you can use substitution method. Okay, I'm not going to go into details because this one we have done it enough already in partial fractions and also in indefinite integral. Right, so we just let x to be negative 2 to find the value for the unknown a, and then let x to be negative 1 to find value for c, and subsequently just let x to be 0 to find unknown b. Alright, so part I is putting them into partial fractions, because only then we can integrate it. Okay. Alright, so this is what I have in part I. So I'm going to integrate 1 over x plus 2, that give me ln bracket x plus 2. And if I'm going to integrate 1 over x plus 1, that gives you ln bracket x plus 1. And this one here, okay, you can write it as bracket x plus 1 to the power of negative 2. So if you're going to integrate it, this will give me x plus 1 to the power of negative 2 plus 1, right? Over negative 1. Differentiation of x plus 1 will give me 1. So that will give me negative 1 over x plus 1. So that explains this part here. And you just put in the limits. Let x to be 3. So I would advise you to do substitution. Do the substitution properly. X to be 3. So 3 plus 2, 5. That explains here. 3 plus 1, 4. That explains here. And then 1/4, and so on and so forth. And then the next thing, of course, you can, the questions did not say leave the answer in the exact form. You can use a calculator. Or if you could leave in the exact form, it's not difficult also. You just have to simplify it further only. Okay, ln 1 will be 0, so this is gone. So that's end up with negative ln 2. Negative and negative become positive. And of course, ln 4, you can write it as ln 2 to the power of 2. Bring the power down so that I can simplify this with this. So I'll end up getting, okay. And how do I get 8 here? That is when I bring the 3 up again to get 2 to the power of 3, and 2 to the power of 3 is 8. Then here I apply the quotient rule. Ln A minus ln B equals to ln bracket A over B. So that explains this part here. So this is leaving answer the exact form. Okay, if the questions did not ask for it, you just leave it to trace significant figure. Okay, so we have done problem sums involving exponential, logarithmic. So how can we miss out trigonometric functions? So for question 16, okay, I know it's tiring. Okay, it's tiring, but it's another 3 more questions and we're done with this assignment. Okay, so don't give up. So for 16 part I, okay, we're just going to differentiate it. So differentiate. If you were to recall how we do differentiation, okay, differentiate ln bracket ax plus b, right? So that gives you 1 over ax plus b, then times differentiation of ax plus b, which is a, right? So we're going to differentiate ln secant x. That will give us, change your secant x to be 1 over cos x, easier. And then apply the logarithmic law, which is if you have ln bracket a over b, that gives you ln a minus ln b, right? So that will give you ln 1 minus ln cosine x. And ln 1 is 0, so that will give you negative ln cosine x. Okay, so simplify it first, and then we're going to differentiate it. Right. So that will give me negative 1 over cos x times differentiation of the cos x is negative sine x. So that will give me tangent x, which is what I'm supposed to show. Alright, so part 2. Oh, just differentiate x tangent x with respect to. Okay, so how do we do that? You just use your product rule. Let x to be u, tangent x to be b. So you differentiate tangent x, you get secant square x plus differentiate x, you get 1. Oh, and this question is just like that. Seriously? Okay, done. Alright, so in this question is actually a part 3. And this part 3 is actually the main dish. Part I and 2 are just a side dish. Because we're supposed to use part I and part 2 to solve part 3. So part 3 is this one here. We're supposed to show that the definite integral of x secant square x is equals to this one here. So let's write down what we have found from part I and part 2. And we're going to use part 2's result. Why are we going to use part 2 result? Because the part 2 result has this term here, which is exactly what I'm supposed to find, you see. So I'm going to add integral sign to part 2. Which explain this one here. Okay, and I'm going to make this one the subject, because this is exactly what I need to find lah. And of course, differentiation integration can solve each other, right? Okay, so there's a tricky part here. What's the tricky part here? I'm supposed to find the integrations of this, right? And where do I get that? That is, I get it from part I. Okay, when I add integration sign to part I, can you see this and this cancel off? So integrations of tangent x dx basically is just ln bracket secant x. Okay, and of course I don't need to add the plus c, because the next step is I'm going to put in the limits already. But add the plus c because I've not put in the limits yet lah. Okay, so yeah, it kind of looks complicated here. Okay, because we have this big portion here that we need to manage. So I'm going to show you how we manage that. Alright, so ln secant pi over 4, we're going to change your secant to 1 over cos. This one, secant is 1 over cos pi over 4, right? And then we're going to apply, your ln a over b. That gives you ln a minus ln b, right? To separate it, to get ln 1 minus ln cos pi over 4. Ln 1, of course, is 0. And cos pi over 4. Pi over 4 is 45 degrees. So cosine 45 degrees is a partial angle which gives you square root 2 over 2. And here again I'm going to apply ln square root 2 minus ln 2. There's a negative in front, right? So that ends up negative ln 2, and negative times negative give me positive. And square root 2, it's actually 2 to the power half, this one here. And that gives you negative half ln 2. So that explains this one here. It's very long. So negative half ln 2 plus ln 2. Okay, so we're going to replace. Okay, I'm going to erase all this. It's very confusing. Alright, so I'm just going to replace this one. This with this. Let's see what happened. Okay, why is it become plus? Can you see there's a negative here? So the negative and this negative become positive. Negative and plus become negative. And how I get pi over 4? Because tangent 45 degrees is 1. So pi over 4 times 1 just give me pi over 4. Alright, and how do I get 0 here? Because tangent 0 is 0, right? This one will gives you, okay, ln 1 minus ln cos 0. Ln 1 is 0. Cos 0 is 1. So again, ln 1 is 0. So that gives you 0 lah. And so you end up getting pi over 4 minus half ln 2, which is what you're supposed to show. Okay, so this is really a very challenging question, long and tedious. Right, we're going to look at the last questions. So the last question says that if you're given the function f of x, and if the definite integrals between a and b are more than equal than 0, are we saying that the function itself is also more than equal than 0 for all x between the limits? Is this statement true? For such questions, we're going to use a counter example. If you can have a counter example, then we can prove that this statement is false. Right, so what kind of counter examples are we going to give? Yes, I'm going to let f of x to be 2x minus 2. Alright, so I'm going to find the area of the shaded region, which is between 0, 1 and 1, 3. Right, so when I'm finding the area between 1, 0, I need to negate it because this part of the area is below the x-axis. It will give me a negative value. So since I'm talking about area, then I have to make it positive. So I need to negate it to make the answer positive. Okay, and if you were to substitute in the limits, like what we've done for the first few slides, right, if you do it properly, you would get the answers to be 5 units, unit square, 5 unit square. All right, but yes, and you see that 5 is actually more than 0, which satisfy this part here, right? Yes. So now we're going to see, we're going to justify this part here. Is your functions 2x minus 2 always more than equal than 0 between 0 and 3? Right, you will see that it's not, because it's only more than 0 here, but it's less than 0 here. This is not all the time positive for 2x minus 2. So hence the statement is false. Alright, so that ends the video on assignment 17.1. So thank you very much for your attention.